Okay, welcome back. Here we go. We are continuing in Module 2, Topic 3, Lesson 2, Activity 5. We're on pages 326 and 327 for this video. Habits of mind, we will reason abstractly and quantitatively, construct viable arguments, and critique the reasoning of others. Problem solving with unit rates. In this activity, you will use unit rates to solve problems involving constant speed and constant pricing. Zoom out some here, see if we can turn on autofocus. In the spring, the gym teachers at Stewart Middle School sponsor a bike-a-thon to raise money for new sporting equipment. Students seek sponsors to pledge a dollar amount for each mile they ride. Nico can ride 12.5 miles per hour. At this rate, how far will he ride in 5 hours? Okay, well, they're already giving us a unit rate because it's per 1 hour. If it doesn't have the number, we know it's per 1. So 12.5 miles per 1 hour. And we want to know how far he will ride in 5 hours. So we're going to multiply that by 5 hours. So if we put that over 1, our hours cancel out, and we're going to multiply straight across. 12.5 times 5. I'm going to do that over here. I don't want to do the calculator for all of them. I'd like you to be able to do some of the traditional multiplication. 5 times 5, 25, carry a 2. 5 times 2 is 10, plus 2 is 12, carry a 1. 5 times 1 plus 1 is 6. And we have one number after the decimal. So 62 and 5/10 miles. If Letitia rides 56.25 miles or 56.25 miles in 5 hours, how far will she ride in 7 hours? So there's two ways that we can do this. We can figure out her per hour rate first. So if we have the 56.25 miles per 5 hours, we can divide that and get the per 1 hour. So if we do 56.25 divided by 5, we get 11.25. So she rides 11.25 miles in 1 hour, and then we need to figure out for 7 hours. And so we'll do it times 7. Our hours cancel. So then we have 11.25 times the 7. It's already on my screen, so times 7. And it's 78.75 miles, or 78.75 miles. I'm going to pause and get another piece of paper so that I can show you this other method that I want to do, because I kind of ran out of room. Okay, so I grabbed a piece of notebook paper. So when we figure this out, we don't have to go to the per 1 hour. We can go right from the ratio they give us to the 7 hours, and it would look like this. So we're starting with 56.25 miles in 5 hours. They're asking us how far in 7 hours. So if I am multiplying that, I can cancel right there and then multiply straight across. And when I multiply that straight across, I get 56.25 times 7 in my numerator. So I get 393.75 miles. And down here I have 5 times 1, or 5. Now, there's no unit down here because it canceled out. So now if I divide that, it's just a simple division problem now. So if I do 393.75, which is still here, divide by 5, I get 78.75 miles per hour. So we still get the same answer. In this one, we didn't go down to a per 1. We just went right from the rate that she was at, multiplied it by 7, which had us dividing by the 5, which in this version, we divided by the 5 first. We did 56.25 divided by 5, then multiplied by 7. So essentially in this one, we did the times 7 first, then the divide by 5. So it gives you the same thing. Okay, next one. Emil got a cramp in his leg after riding 27.5 miles in 2 hours and had to stop. If he hadn't gotten the cramp and had continued to ride at the same rate, how far would he have ridden in 3 hours? So we can do the same thing. So 27.5 miles in 2 hours is 13.75. So 13 3/4 miles per 1 hour. And then if we multiply that by 2 hours, so, and I want you guys to kind of get used to having something here on your screen on your calculator, and then I don't have to clear it and enter 13.75 again. It's there. So just do times 2. So, oh, nope, it meant 3 hours. I'm sorry. I was like, wait, that's what we started with. 3 hours. Okay, so 13.75 times 3, 41.25 miles per 3 hours. Now, I'll show you the method I used on the notebook paper. We could start with the 27.5 miles per 2 hours, and we can multiply it by the 3 hours. Our hours cancel out. And now we have 27.5 times 3. We get 82.5 over 2. And when we divide that, we get 41.25 in the 3 hours. Okay, moving on. Beth, Kelly, and Amy are all training for local marathons. Beth can run 6.5 miles per hour. At this rate, how far will she run in the first 3 hours of the marathon? So 6.5 miles per hour. I'm going to multiply that by 3 hours. And we get, see, 19.5 miles. Kelly runs 13.5 miles in 2 hours. What is her rate? So 13.5 miles in 2 hours. So it wants to know her rate per 1 hour. So that's just the simple division. So 13.25 divided by 2 is 6.75 miles. And then this one is, it's asking for rate, so per 1 hour. Letter C, Amy wants to run the 26.2 miles of the marathon in 4.5 hours. At what rate will she have to run to reach this goal? So she wants to cover all of it in this amount of time. So we need to find out what miles per hour she would like in order to reach that. So if we have the 26.2 miles, which is how far she wants to go, and she's going to do that in 4.5 hours, and we're trying to figure out that rate for 1 hour. So we're just dividing that to get it down to a unit rate. So 26.2 divided by 4.5 is 5.8 miles per hour. At a workout designed to increase speed, Beth runs 800 meters in 2.5 minutes. Kelly runs 1,600 meters in 4.5 minutes. Who ran faster in this workout? Okay, so let's see. Beth is 800 meters and I'm going to say 2.5 minutes. And then Kelly's is, I'm going to do Kelly in a different color. Kelly is 1,600 meters in 4.5 minutes. Okay, so if we divide them out, 800 divided by 2.5 is 320 meters per 1 minute. And Kelly's 1,600 divided by 4.5 is 355 point, really we're going to round it up to 0.6 meters per 1 minute. So who ran faster? 320, 355, so Kelly ran faster. Okay, moving on, next page. Maya left her notebook on the bus and her friend Amanda picked it up for her. On Saturday, they decided to meet to exchange the notebook. They live 7.5 miles from each other and plan to walk and meet between their homes. Ariana can walk 3 miles per hour. Maya can walk 4.5 miles per hour. Maya makes the suggestion, it will take the same amount of time if you stay put and I run 7.5 miles per hour. Is Maya's suggestion correct? So I want you to pause this. I want you to try it, think about it. I want you to draw yourself a picture in this box to try to illustrate that, please. Okay, so I have a little sketch drawn. So if Ariana is over here and Maya is over here, such a great artist, and we're going to look at the first scenario. They live 7.5 miles from each other, so there we go, the 7.5 miles. Ariana can walk 3 miles per hour, so of this 7.5 in 1 hour, she can make it 3 miles. So Ariana might make it, I don't know, let's say it's this far in 3, so that's 3 miles in the hour. And Maya can go a bit further, so Maya is covering the 4.5 miles, or 4.5, however you want to make that. So they meet right here. This is kind of your X marks the spot. Now, Maya says, if you stay put, I can get there in the same amount of time. So, is she correct? So it takes 1 hour for each of them to get here because she's gone 3 miles per 1 hour. She's gone 4.5 miles per 1 hour. So in 1 hour, they meet here. Well, let's think about Maya's. Maya says, it will take the same amount of time if you stay put and I run 7.5 miles per hour. So if Maya is starting down here, but instead of traveling at a rate of 4.5 miles per minute, she runs the whole thing at 7.5, I'm sorry, not per minute, per hour, miles per hour, she will in fact cover the whole thing. So Maya is correct. So yes, Maya would cover the 7.5 miles. Okay, pause if you need to. A carpet store sells carpet by the square yard. Classroom carpet sells for $10.50 per square yard. So it looks like they want us to figure out what it would be for each of these additional square yards. I want you to pause and give that a try and then come back. Okay, so all we're doing here, and I've done the first part already here for this next box. So if 1 square yard is $10.50, then 40 square yards, we'll do $10.50 times the 40, and that's going to be $420. Dollar sign in front, please. If I did 50 yards, the 1050 times 50 yards is $525. And then if I did it times the 100 yards, we're just moving the decimal over 2 places, so this will be $1,050. Okay, similar thing here at letter B. A grocery store sells Pink Lady apples by the pound. 1 pound of Pink Lady apples costs $2.99. So how much will it cost for 2 pounds? 5 pounds, 10 pounds, and 20 pounds. So please pause and fill that out. Okay, so hopefully you paused and did that. So if I double $2.99, that's almost 3 times 2 is 6, but it's a penny off on each, so $5.98. So if I did $2.99 times 5, I'm at $14.95. The 10 pounds, we're just going to move the decimal point 1 to the right. We're multiplying by a value of 10. So it's getting 10 times bigger. So that's going to be 29.9, or since it's money, we'll put a 0 on the end. And then for 10 to 20, I can just double this. So if I double that, 0, 18, I'm going to carry a 1, 19, so $59.80. How did you use a unit rate to complete each table in question 4? So I multiplied the unit rate by, let's see, and in letter A, I multiplied it by the number of square yards. And in B, I multiplied it by the number of pounds of apples. Okay, we'll see you on the next video. Ask questions as you need, please.